All right, here we go again. Example 3B. Once again, they gave us a couple of vertices, which I've graphed in blue. And then they gave us a few asymptotes. Unfortunately, they screwed up their signs here. I'm going to give the textbook manufacturer the benefit of the doubt here and assume what they meant was 2x plus 12 and negative 2x minus 12. Had we have graphed the asymptotes the way they were presented to us in the book, they would have met over here at 6, 0. I'm assuming that's not what they meant. So after we adjust for the sign error there, we get two asymptotes that meet at negative 6, 0. And again, asymptotes are useful for a ton of things. In particular, they can help us find the center. Where the two asymptotes intersect, that is the center of our hyperbola. So our center in this case, negative 6, 0. Note that our vertices are along a horizontal transverse axis this time. So it's going to open left and right, our hyperbola here. So we have a bunch of information, but we are missing a key component. We've got our center, that's h and k. We also have our a value here. Keep in mind, a is the distance between the center and a vertex. What we don't have is b. Note that they didn't ask us to graph, so we also don't have c. But we're not as worried about the foci for this problem. In order to get that standard form equation, for sure I need a and b. Not having c isn't the end of the world. So it comes down to that idea of slope. And for a horizontal, in other words, left and right opening hyperbola, that slope is plus and minus b over a. So keeping in mind that there is a flip there that happens, you get the reciprocal for a vertical asymptote. This is absolutely one of those things worthy of some space on your note card. So I was given the asymptotes. I like to work with positive numbers here, so I'm going to use the positive 2. So b over a is 2. Again, you could do the same thing with the negative values. I like working with positive numbers. So b over a is going to be 2, and we know our a value. A was 3. What's the opposite of divide by 3? Goodbye. So we can find our b value that way. So I now know my h, I know my k, I know my a, I know my b. We also know that this hyperbola opens left to right, it's horizontal. So our standard form will be x minus h quantity squared minus y minus k quantity squared. We get an a squared underneath that x. We get a b squared underneath that y. Whole thing equals 1. This is our standard form for a horizontal hyperbola. Now we're just substituting in what we know. Our h value was a negative 6, so x minus a negative 6 will be x plus 6, quantity squared. Be careful with that a. We know that a is 3, but in that denominator ought to be a squared. 3 times 3 is 9. Minus is a part of the formula. You can write y minus 0 here if you like. If that helps you with graphing, then I recommend it. Since we don't actually have to finish this graph, I don't know how useful that is. So I'm just going to write y squared. We found our b value. B is 6. Again, we want to be careful. If b is 6, then b squared is 36. 6 times 6 is 36. Whole thing equals 1. Throw a box around it, you're done.